Hello everyone. My name is Baran Ataman. I would like to present you my applied electromagnetics term project. We were assigned to design a cavity resonator with our own hands. A cavity resonator is primarily used for energy storage at very high frequencies where RLC circuit components are not efficient, not robust. Uh, we designed a cavity resonator in our preliminary work. Then, in real life, we found a shoebox which would be suitable for our experiment, our project. The dimensions are 30 centimeters, 14 centimeters, and 40 centimeters. We covered inside of this resonator, this shoebox, with aluminium folio, and these are the illustrative figures of our cavity resonator. Here is our cavity resonator, and here is its inside. We tried hard to straighten the folio inside the shoebox, and a few calculations we should emphasize. The resonance frequencies for each and every mode is given this. The corresponding wavelength is also here, and since our dimensions have the relationship which the C has the highest and B has the lowest, our lowest mode is TE101 mode. We calculated the resonant frequency of this mode. It turned out to be 620 megahertz. Corresponding wavelength is about half a meter. We have a quality factor about 1100. This quality factor is not so big as expected because we have aluminium folio, which is not a perfect conductor, but it uh, provided us a relatively large bandwidth. And also, since we have three different dimensions, not a cube in our hands, we have different modes of uh, resonance. The second most dominant mode is TE011. It has 1.15 gigahertz, and the third dominant mode is TM110 110 mode, which has 1.3 gigahertz. And another theoretical aspect of this project is the antenna locations. We have to put the antenna where the electric and magnetic fields are the highest, and we saw that we should place the antenna middle in both length and width. So the antenna should practically be at the center of the cavity resonator, and the antenna length should be the 1/4 of the wavelength, operating wavelength of the standing wave. So for our dominant mode, TE101 mode, we have half a meter of wavelength, and our antenna length should be 11-12 centimeters. So let us just come to the experiment part. We saw that with, via network analyzer that we have two dominant frequencies below 1.5 gigahertz. They are around 610 megahertz and 1.09 gigahertz resonance frequencies, which are very expected. We placed the other antenna for the second part. We gave 1.7 volt from the network analyzer and obtained 1.05 volts. As we calculated the loss here, we get 4.1 decibels of loss, which is an acceptable loss. And for the second resonance frequency, we have given 1.4 volt at 1.01 gigahertz and obtained 0.5 voltage output. And again, calculating this, we obtained minus 8.8 decibels, which is not that bad, but of course a little bit less accurate than our first dominant mode. So these two types are the resonant frequencies below 1.5 gigahertz. Thank you for listening.